converting from vertex form to standard form. In today's lesson, we're going to be continuing with what we did in 311 with vertex form, but today we're going to take that vertex form and convert it into a different form of a quadratic called a standard form. If you'll remember that vertex form was written as y equals a times x minus h. I'm going to square that, then add k. And if you'll remember, the h and the k give us our vertex, so it makes it a little easier to graph. And then the a tells us which direction the graph opens up. Okay, the vertex comes from h and k, and a tells us which direction the graph opens, up or down. We also get our axis of symmetry from that vertex point also. Well, in today's lesson, we're going to look at standard form of a quadratic, and here's how standard form is written. And if you'll notice, it still has the a, which tells us which way the graph opens, up or down, but it does not have the h or the k. So this does not give us the vertex form. That does not give us the vertex. We have to have this equation in vertex form. But it is going to give us something else that will help us on our graph also. And we'll see that as we go. Okay, so we're going to convert each of these into standard form. But before we do that, we're going to go ahead and review what we did in the last lesson. Alright, so let's go ahead and do that. The first thing is we're going to write the vertex. So our first equation is y equals 6 times x plus 1 squared minus 4. Remember, the vertex comes from this and this. Okay, that 1, that gives us our h, but remember we have to take the opposite of it. So since it's positive 1, the opposite is going to be negative 1. And then the negative 4 is our k, and remember, since it's on the outside, we leave it negative 4. So there's our vertex. Alright, which also gives us our line of symmetry, or axis of symmetry. Remember, it's x equals whatever that h value was we put there. Now, since the a in this is 6, it's positive. Since it's positive, that means the graph is going to open up like that, and the vertex is going to be at the bottom of it. So that's what we call a min, or a minimum. Alright? Now, the next thing we're going to do is we're going to skip over D, the y-intercept, because we're going to get that when we get this thing in a standard form. Okay? Now let's put it in standard form. All we're going to do to put it in standard form is just follow our order of operations. So I'll start working through that. Remember, order of operations says to do what's on the inside of the parentheses first. I can't add x and 1, so I don't do anything there. The second thing it says to do is the exponent. So what this means is I have y equals 6. X plus 1 squared means I just have that twice. X plus 1 times x plus 1. And then I'm going to subtract 4. So I'm going to have to do all this multiplication, then subtract 4. So I'm going to multiply x plus 1 times x plus 1. So you could do it using your box if you want to. Alright, and when I multiply those together, I get x squared, 1x, 1x, and 1. And remember, these two add together to make 2x. So now I have y equals 6 times x squared plus 2x plus 1. And I got to subtract 4. Now before I can subtract 4, I still have to distribute this 6 in. So that gives me y equals 6 times x squared is 6x squared. 6 times 2x is 12x. And 6 times 1 is 6. And then I have my minus 4. So the last step is to combine those like terms. The 6 minus 4. And I have my new equation is going to be y equals 6. Oops, let me fix that real quick. y equals, do this again, 6x squared plus 12x plus 2. That is my equation written in standard form. Now let's go ahead and look to find the y-intercept. Remember the definition of y-intercept, it's the value of y when x equals 0. So what is y when x equals 0? So if I put a 0 in, put a 0 in for this x, put a 0 in for this x, alright, that gives me 6 times 0 and 12 times 0. Those both just go away, and I'm just left with this 2. So the y is going to equal 2. Now for all cases it's just going to be the c, because if I put a 0 in, if I look back up the equation, if I put a 0 in for that x and a 0 in for that x, both of those things will go away, and I'm left with y equals c. So that's the formula for finding the y-intercept. Okay, so remember y-intercept is y. I'm not going to write it as y equals. I'm going to write it as 0 is my x and 2 is my y. So let's just start plotting this stuff. Let's plot our vertex. Well, first of all, let's do our line of symmetry at -1. We'll put our vertex at -1, -4. I'm going to change colors on that. Let's make it blue. And then I'm going to also put my y-intercept at 0, 2. And that just gives me another point to graph. And so I'm going to draw my graph. It opens up. It's going to look something like that. It's not very pretty, but it's a good rough sketch. Okay? Alright, why don't you try example number 2 on your own. And so pause the video. When you get finished, go ahead and start the video back up, and you can check how you did. Okay, go ahead and check your answer. See how you did. If you'll notice, the vertex is 2, 4. That 2 comes from the opposite of -2. It's a max because of the a was -2. So it's going to be a max because the graph is going to open down. The line of symmetry is x equals 2. That comes from your h. And then when you look down, that you get the y-intercept is 0, -4, because when you solve into standard form, you get the equation in this form, and that c value is -4, so that's going to be our y-intercept. Then when I graph all those points, the graph the line of symmetry, the vertex, and the y-intercept, you get a graph that looks like that, opens down. Okay, if you have any questions, go back and re-watch parts of the video if you need to. Make sure you complete the whisk before you come to class, and we'll see you there for some practice.